All right, so continuing on our Spark theme, next up is Nicholas and Alejandro, who actually will be taking us through a cage match between Spark and Hive. So take it away, guys.
Yeah, let's the audience set up.
Yeah.
Come on.
Oh, yes, but you also need to take a mic for the recording.
All right. First of all, thank you very much for attending this lightning talk. I'm Alejandro Montero, master student at the Barcelona Supercomputing Center. And in the last couple of months, we've been working with BigBench to compare the performance of different big data engines. Specifically, we're focusing on Hive and Spark. So BigBench is a specification-based benchmark with an open source implementation. And recently, it's been proposed to be the first big data benchmark on the world. And that's because right now, it's the only one that covers all major big data characteristics. And as you may know, they are the volume, variety, and velocity. Some very quick characteristics of BigBench. It's an extension of TCP/DS that adds some new SQL queries and use cases such as machine learning, natural language processing, some others. It can support multiple implementations, engines, and table formats for Hive. It can also execute multiple parallel streams at the same time in the same cluster, and it can define different scale factors. We used scale factor of 100, which is approximately 100 gigs in table size. So BigBench, what it's doing, it's emulating a store that is selling items, both physically and via web page. And for that reason, it provides this data structure. First, we have the structured data, which is the one we're used to, easily indexed and recoverable. And we add two more, which is the web log, which contains the click streams of every user that is navigating through the web page. And the reviews of the users that actually have bought an item and want to make a review. So for the workload itself, there's 30 queries divided in 4 kind of use cases, 14 pure QL queries, which retrieve information from the structure section. Then we have 4 queries of MapReduce, pre-processing of the data before selecting it, 7 natural language processing queries, and 5 machine learning queries. So don't be overwhelmed by this. This is the software stack of the implementation we've been using. Very fast, starting from the bottom to top. All files are physically stored in Hadoop distributed file system. But as we're running queries, we need to have a middleware, a metastore to store the logical tables. And on top of that, we need a SQL engine that is receiving the queries from BigBench. It's parsing them, and it's retrieving the information from the metastore. Once we have the location of the files we want to recover, we can use one of these 3 engines, one of the execution engines, to actually retrieve the physical information from each DFS. The engines can be classic MapReduce, tests, which maybe you don't know about it. It's a hack on top of MapReduce to create a direct acyclic graph to reduce latencies and improve overall performance of mappers and reducers. And Spark engine. And for the machine learning queries, we also need a new application to perform the learning techniques. And we can use 2 applications, Mahout, which is based on MapReduce, or Spark MLlib, a custom-built Spark MLlib library. So, of course, John is the one that's managing all the containers for every single application in here. So we benchmarked all permutations of the engines you see in this slide. But we still have a few work in progress things. We have some results for Hive 2, but they are quite odd, so we're still working on that. And also for Spark 2, it was compatible with Mahout, but the custom library was not binary compatible with Spark 2, so major code refactor is needed, and we hope to get results pretty soon. Hardware-wise, we're using an HD Insight platform as a service cluster, model D4B3, with 4 working nodes, featuring a high-end Intel Xeon CPU with 8 cores, 28 gigs of RAM, and the HDFS is completely remote. For the software stack, AGI is relying on Hortonworks Data Platform 2.5, we've noticed that both MapReduce and test are really well tuned, so we decided not to change a bit of the configuration. What we did notice, though, is that Spark was recently added, and the configuration is quite strange. It's only using one executor per working node, and that executor has 3 out of 8 cores available in the machine. So for the results, we decided to divide it in use cases, starting for pure QL. As expected, MapReduce is the slowest one on the group, followed by the fastest one, which is Spark 2, which is very close to the other engines, Spark 1 and Hive tests. We wanted to see a little bit more what was happening inside a pure QL query. So this is a trace of the CPU behavior of one of the queries, query 12 to be correct, consist. What we can see here is that tests, it's reaching 100% of the CPU usage, which indicates it's CPU bounded. And also in this case, you cannot see the numbers because of resizing reasons. Well, it's a lot faster than both the other engines. Test is finishing in 100 seconds, Spark is finishing in 200 seconds, and Spark 2 in 160. Moving on, we see that Spark 1 and Spark 2 both are reaching a top of 30% of CPU usage. Sorry, you cannot see the y-axis. Most interestingly, we can see that Spark 1 has a lot of I/O wait for some reason. And Spark 2 deals with that. It doesn't show any more I/O wait, and it ends a lot faster in this case. Also, it is using only 30% of the CPU, and that may be because of the software configuration I just talked about you. For very fast, for the second use case, custom reducers to pre-process the data before selecting it, we see that Hive test is the fastest one here, followed by Spark 2, and very close to Spark 1. MapReduce again is the slowest one. Moving on, natural language processing here. Tests, once again, it's the winner by a long shot in this case, followed by Spark 2. Spark 1 is really close to Spark 2, and MapReduce is really, really slow. And finally, for the machine learning sections, we can see 2 interesting things here. First of all is that changing one execution engine for the other doesn't bring us any real difference in performance. But what does give us a difference in performance is changing the application that actually performs the machine learning. And changing from Mahout in any of the engines to Spark MLLib gives us a 2 times improvement in performance. As I said before, unfortunately, we were not able to test Spark 2 with Spark MLLib, but we're hoping to see 2 times improvement as well, as in the other cases. And finally, for the aggregated results for the 4 use cases, what we can see is that for the whole group, the fastest one here is test plus Spark MLLib. Second in line is Spark 1 with Spark MLLib, followed by Spark 2 plus Mahout. We're hoping to see Spark 2 plus Spark MLLib to be a lot faster when we have results, but right now it's on the 3rd position, and MapReduce is the slowest one on the group. So just to finish, some conclusions we can gather from these results. First off, Hive plus test is improving SQL performance by a long shot over MapReduce. It's slightly faster than Spark 1, but it's slightly slower than Spark 2. And we have to make clear something in this point, is that the implementation Spark of the queries, the implementation Spark is using is the same as the Hive one. So they are using the very same SQL queries. And in this implementation, these queries are very optimized for Hive. So maybe tweaking for Spark may give us a different results. Second conclusion we got from this study is that Spark MLLib is way faster than Mahout. We encourage you to use it instead of it. And finally, the best production company at the moment is using Apache Test for the SQL sections of your queries. And if you need to do machine learning techniques, stick with MLLib, which is the fastest one. So before finishing, I encourage you to assist tomorrow to a presentation my colleague Nico is doing using a non-volatile memory to improve performance of HBase, Hadoop, and other stuff. Quite interesting, building U at 12 o'clock, so encourage you to attend. And that would be all. Thank you very much. If you have any question.
one question. Any questions? Anybody? All right, well, thank you so much again.
Thank you.